We are pretty hardcore nerds.
I'm not against saying it. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 329, AI surgery, a prison camp lathe, and a One Hertz Four-Fer. A bunch of you have asked if we have speaker announcements yet for Supercon. Call for proposals ended a week ago. We have an anonymized spreadsheet with everyone's proposals on it. We've circulated it around. We're all poring over them to figure out a good slate of talks, and we'll get back to you soon. Our deadline for having them all done was next week sometime. So if you've submitted a talk, rest assured we will get back to you in the next week and a bit as you listen to this.
Going through the talks is always it's a challenge that I enjoy. It's always a very hard decision to make because we get so many incredible proposals, and obviously there's only so many hours in the weekend. It's a highlight and a low light of my summer, if that makes sense, because it's a very hard call to make, but I do love seeing what everybody's working on and the passionate proposals they make, and it's a burden I willingly carry. Let's put it that way.
We do try to keep the talks fresh. Like, we don't run the same people year after year. So, we try to keep space for new people who've never given a talk before, as well as space for obvious, awesome talks. It's the mix. It's the mix. This week in Newsy News, Maya Posh wrote it up. The Vendelstein 7X sets new record for the nuclear fusion triple product. And if you haven't seen the Vendelstein reactor, it is crazy. It is a stellarator fusion reactor, which is my favorite because you can go stellarator. But also, we'll talk about that later. But also my favorite because as opposed to the boring tokamak, which is basically shaped like a donut, this is shaped like a swirly donut. It's oblong and then it curves as it goes around. It's not just because it looks cool and organic. It's actually because the path that it bends the plasma around is easier to contain when it's in this shape. And they've gotten a brand new record that is the hottest and longest plasma running yet. Although, and this is what I love about science, there are two versions of the graph here. The one that Maya puts in the paper is the one that also contains some results from a tokamak project, the JET, which hasn't published their results officially yet, but may have almost as good a fusion run going on there. What's the triple product? It's a measure of the kind of break-even energy generation versus energy into the generator. And this is getting closer and closer. They're not expecting break-even yet. There's no surprise there. But they've managed to get their hot plasma running for 43 seconds. They've actually kind of retrofitted the pellet injector from the Lawrence Livermore Labs thing into this. So it throws little hydrogen pellets in there to keep feeding it because otherwise stuff gets consumed. 90 frozen hydrogen pellets, each about 1 millimeter in size, were injected over 43 seconds while powerful microwaves heated the plasma. How hot, you might ask? Plasma temperature was raised to over 20 million degrees Celsius, reaching a peak of 30 million degrees. Yeah, that's hot. Don't get it on you.
Yeah, for technology that's perpetually 20 years distant, I feel like the 20 years is getting shorter.
It does feel that way, right?
This might be the shortest the 20 years has ever been.
20 years is maybe 30 years at this point. It's the shortest, like you say, shortest it's ever been. One of the reasons that Vendelstein gets a sweet spot in my heart is that it's done basically on the cheap in terms of fusion reactors. Like, in terms of, your money and my money, it's fairly expensive. I think they've blown like $1 billion on it over the last 15 years, 20 years. But, that's a lot of people's salaries and a lot of superconducting magnets and, a lot of energy budget and a lot of science getting done. So it's actually, when you compare it to any of the other fusion projects out there, it's by far the cheapest and running so far by far the most successfully. And that's really cool because it's kind of an oddball design. So, I'm rooting for the little guy.
I like that.
This is is a journey into sound.
What's that sound?
What's that sound?
Well, shall we head on off to What's That Sound?
Of course.
You're going to love this one.
I'm gonna love it.
I'm going to tell you right now, you will not get it, but
I think I knew that anyway.
I'll give you $20 if you can guess how it was made.
Okay, let me see. What the? Wow. It's like a nightmare? This is like a clown stalking me at night.
Crisp $20 bill remains in my pocket.
Wow, that is an uncomfortable sound. Like a bellows of some type, maybe.
Okay.
Some pistons. I got nothing. All I know is I don't like it. It speaks to me on some kind of level that I'm unhappy with.
Fantastic. Will possibly surprise you then to hear that it's a piece of music.
Oh, wow.
So extra credit for people who can guess the name. If you can't, and you can just guess how it's made, well, honestly, if you can guess how it's made, that'll probably get you the name. Good luck, our listeners. Those of you who are experimental music heads, you've got this one in the bag already.
Man.
We'll see who the hardcore are. We'll see who the real heads are next week.
I'll have to miss that concert. Whatever day it is, I'm sick that day.
Tune in for the big reveal next week. If you do know what it is, get your guess in over at hackaday.com/podcast. Scroll on down to the What's That Sound. Click there to fill in the form with your guess and your handle and your email. And a lucky correct answer will get a Hackaday Podcast t-shirt. All right, let's start talking hacks. This week I wanted to start off with, well, totally not a hack. It's a medical advancement, but it's an interesting one. Comes from researchers at Johns Hopkins University. Our title is, Do You Trust This AI for Your Surgery? And according to Beveridge's law of headlines, the answer is no. And no, you don't trust this AI for your surgery. Maybe unless you're a pig with an inflamed gallbladder that needs removing and you are in this experiment. Because that's what they trained their surgical robot to do. It's actually really, really neat because, a lot of surgery these days is done with these Da Vinci surgical robots because they have scissors and grippers and all of this on tiny little long arms. So you can get into people with a small hole and do everything remotely endoscopically. And usually they're steered, driven, whatever, by a trained surgeon with these crazy multi-dimensional controllers. They're really awesome. This one is driven robotically. And so what they did was they trained a neural network to take images and learn how to maneuver the, little snipper and the clipper and all of the little surgical robot parts to where they need to go. So they have one model that kind of takes an image of the tools, in the scene and knows how to get it there. There's another neural net upstream of that then takes commands and integrates them with the current video feed and knows where to move the manipulators. And then there's another neural network up ahead of that takes these and turns them into kind of human language. In between these, there's a kind of a gap where they can press the stop button and say, move the actuator a little bit toward the camera, move it a little bit away from the camera. They have a stop button that says stop and reconsider things. And it's really neat because they've trained this system of kind of cascaded networks on actual surgery done on actual pig bladders outside of the pigs, by the way. Ex vivo is the term for this. But they've actually trained these on something like 30 surgeries and then let it loose on 8 pig bladders, and it works. On one hand, the surgery isn't very complicated. It's cutting 2 parts of the bladder, and so it puts a clip on either end so that stuff doesn't leak out and cuts in the middle, and then it does this again. This is actually really tricky though, because, not everything is exactly the same. So the image recognition algorithm actually has to do some real work here to figure out where it needs to put the clips and where it needs to cut, etc. And that's really neat because previous efforts to do this have relied on doctors going in first and tagging the parts. They've done it with like optical markers and, tagging them and then getting a robot to automatically, quote, automatically do the surgery there. Here it's actually like looking at the scene and understanding the surgery well enough that it can do that. So the system does 8 out of 8 test pig bladders correctly. It does them all slowly. It's something like 5 to 7 times slower than a human operator, but humans are really good at this sort of thing. The clips before the cut aren't placed in really the optimal positions. Like they could be closer to either ends, leaving more space in the middle, but good enough is good enough. What's fun is that the addition of the intervention in the training set, so the bit where they can say, oh, here, stop, now move it a little bit to the left, actually is part of the running of the system too. It has its own, hey, I should stop, something's not right code that it can flag itself with and then move it. And what's funny is that it does 4 to 12 of these stops and interventions and repositionings along the way in the different trials. And so it has to cut basically 2 pieces of tissue. In one, it gets around the wrong one before it gets to the one it's aiming at, and it backs out and it goes around and does it. So that's actually really cool. This is way far from being able to do it on live anything, much less humans. So, don't fret. You hopefully will be able to get a competent surgeon to do work on you. But it's also so much progress on this front in the past 3 years. And I'll throw a link to the last time we've written something on robotic surgery. It's actually the precursor project to this, also at Johns Hopkins. It's the one where they were flagging the parts and basically saying, here, robot, cut here.
Like you started out with the headline, do you trust this AI for your surgery? And the answer is no, now, right? But this is an exceptional chance that this is the shape of things to come. As skeptical as I am in general of a lot of this AI for certain tasks, I can see, how a specially trained model could have benefit in the OR, right? And maybe not even necessarily in your average hospital, but I'm also thinking stuff like remote stations. If you're in Antarctica and something goes wrong, I mean, it would be helpful to have the sort of AI medical compendium that you could reference and say, all right, look, somebody's in front of me dying. What exactly should I do about it,
This is so far from that, it's not even funny. This is really, we've trained this one particular, 5-step procedure, and we've got it trained on this. So, don't worry about it combing the medical literature yet. It doesn't even know, anything like that. But it is really cool that the computer vision side of things can build up enough of a model that it can get in there and get the snippers around the right tube. That's pretty cool just by itself. Do note the bulk dissection, like just getting down to the part where they could actually do the hard part of the surgery was all done beforehand. This isn't even it's cutting it open. This is someone dissected it down to the part where they have to do these 2 clamps and 2 cuts, and the robot can do the 2 clamps and 2 cuts. What's funny here is that that's still amazing. Like, it's something you probably could train a person to do. Actually, I don't know. It's pretty hard. Being a surgeon, I think, is harder than I think it is. But
That's probably a fair assumption.
let me back that all up.
I played a simulator one time, but if you got it wrong, it just buzzed at you if you took the wrong thing out of the body. So I don't know if that counts.
I've played that one too.
I got pretty good at it though, so I think I'm ready to operate on the pig bladder.
I think you are.
So my first one this week is, will HP create a Carfax system for PCs? I should say I don't know that I agree with the actual comparison to Carfax once I got a little bit deeper into this. For those who might not be aware, Carfax is, you can get the VIN for a used car and punch it in there and I'll tell you, oh, it had an accident, it had a whatever. It struck me as kind of weird. My computers don't have too many accidents that were, you know what I mean? Like, I didn't really get the direct comparison comparison, but if you read this more, what HP is really talking about here is kind of almost more like a black box for the computer that's going to record all kinds of metrics about usage and temperature and CPU stress levels and try to create this record of how used a computer is. From what I took, it wasn't even really talking about maintenance so much. It was just how much work has this machine put in, and the flip side is how much more work can you expect to get out of it before it croaks, right? Their idea here, or at least what they're publicly saying, is, oh, well, you'll have a better feel for when it's time to replace the machines, and you'll be able to eke a little bit more usage out of them, and that means less e-waste and yada, yada, yada. The more skeptical of us will probably look at this as, another way to implement like planned obsolescence, right? I mean, I don't like the idea of my computer deciding when it's had enough, right? Like you will continue to work until morale improves, right? I've got stuff that by any reasonable calculation should have been put to pasture long ago, and I'm sure there's probably people listening here that are in a similar situation. I mean, I think piecing some machine together from obsolete stuff is sort of a hallmark of the home hacker. The idea that we could see a future where a motherboard says, "Hey, you know what? I'm just tired, boss. I can't do it anymore. I've ran too many hours and it was too hot and I don't want to do it. It's time to send me to your authorized rehabilitation center." Like, that worries me, and I do kind of see that this could be a foot in the door towards that. The commenters point out that we already have a lot of systems, granted on a per device level, that do this. Like the smart status for hard drives can already tell you how many hours they've been run for, how many starts and stops, and what was the hottest they ever saw. So we have that to a degree already. I don't know that reinventing that really has any benefit. It just seems like a solution looking for a problem. But I guess that's how you make your money anymore, right? Like, you gotta keep coming up with more solutions for more make believe problems to get somebody to invest.
If I can be devil's advocate here, I do think this is aimed at large businesses that have
sure.
If you've got like a fleet of 3,000 HP laptops that you need to maintain, it's probably good to know when one of them's about to go bad, if you can get that sort of information out of this, right? Like, if it's like, this one, maybe it's time to replace, this one has been left in the closet and is probably all right. It could probably save corporate from replacing a couple of them. Will it bring Tom anything? Sometimes I type on a 2011 ThinkPad, right? Like,
yeah, right.
Like, I've bought 3 different batteries for this thing, but the damn computer just keeps on going, and like, the screen's beautiful. What's it gonna do? It's not gonna break. The poor thing suffered, but you clean the sand out of the fan and it works again. It's not a problem. I'm with you a little bit. I don't know when has a laptop had enough.
Who is to say when that, like you said, you're using a laptop that is, over a decade old and still works. I don't know that there is a way to just look at a spreadsheet of numbers and say, okay, this computer is done. I think it's done when it doesn't turn on anymore.
That's right. I'll tell you when my laptop's broken.
I don't know that there is, and I mean, I'd be curious to see if there is some kind of pattern. You could say, oh, well, it was X amount of hours run at too high of a temperature, so maybe the solder joints on the board are suspect. But even that seems like it's really pushing it, and I think a lot of us are probably using, in some capacity, things that would have been tossed out twice over. I myself have an ancient ThinkPad or two laying around that still turn on when I need them to, right? So, what would have happened if their number had come up? What would have become of them? If it worked really well in that corporate environment, who's to say that somebody wouldn't say, hey, well, I got an idea. Why don't we start moving this to the consumer stuff? And you get a little notification on your desktop like, so sorry, your computer has deemed itself to be too old, and you'll need to go to your nearest big box retailer to pick up a replacement. Clearly, like, hardware is moving towards this disposable model, right? The average person, like, oh, my laptop broke, I'll just go buy another one for $300. It is so surprising that in the future your laptop might just say, hey, it's it's time for you to trade it in and, act now. And if you trade me in, you'll get 20% off the purchase of your new machine.
Man, before you were talking about old laptops like escaping their death, and I had this vision of like Logan's Run for laptops, Your citizen laptop, your time is up, but it's like running for the border, trying to get away from the death machine. I hear you. I hear you. Well, my next hack is two hacks. They're both robot hacks. They're both robot dog hacks. The first one is a budget quasi-direct drive motor inspired by MIT's MiniCheetah. This is a really cool project. It is a ground up robot actuator, and the kind that has a gearbox integrated in with the motor and electronics to make it so that you have precise positioning, but then also torque feedback and everything like that all in one. Really fantastic. These sort of motors used to be outrageously expensive. MIT's MiniCheetah project brought them down to the level of not so expensive if you're a well-funded research institution, which is like $800 to $1,000 a motor. And if you don't know the MiniCheetah project, you should check out Ben Katz's work on that. His write-up is fantastic. I know we've covered it before on Hackaday. I'll throw links in the show notes for you. This here is Caden's own MiniCheetah-like motor. And I say like because it's a lot smaller, it's a lot cheaper. He has a total bill of materials at about $80, but that's because he's doing it all himself. And all is including 3D printing the stators, positioning all the magnets in it, winding the coils, etc., etc. The only thing he's not doing is the drive logic, and he's using the MKX X-Drive Mini, which is the old open source version of the ODrive motor controllers. I think it was ODrive 3.6 or something. The company decided to take its controller closed source and sell them for a lot more money. This is the old pre-closed source version made by a company called MKS. And the good news is you can get those for like $30-40. So that is basically half the bill of materials right there. What's fun is the reduction drive here. So it's a brushless motor with a fairly big stator so that it's got a lot of torque. And he fits the gearbox inside the stator, designs his own gearbox. It's all 3D printed. It uses an interesting choice of kind of cycloidal gears. Heads up, gear nerds. Instead of the usual involute gear profiles, which you're used to, these ones have cycloid gears. So it looks like they're kind of like, it's almost a half circle. It's the shape that a circle traces out when it rolls across a flat surface. Caden says he did it because they're easier to print. They have better 3D printing properties. They also kind of are a little bit better for backlash than the normal kind of gears you're used to, which really matters for these motors where you're trying to do super precise positioning and stuff. So it's a really neat choice. Caden couldn't figure out the shapes for these, and so he took some other open source software and edited it himself to make it spit out the gear profiles he wanted here. So this is actually completely custom gears, custom to the level that Caden modified the software to generate the gear profiles, which I think is really awesome. Seeing it all come together is of course fantastic, and that they perform for so little money is really super, because when you make one of these dog robots, I'm saying the difference between, $1,000 motor and an $80 motor, but you have to imagine that your robot has 12 of these on it. And then it's the difference between something that's completely unaffordable and something pretty expensive, but you could totally do it to have a sweet robot dog.
My response to this one is probably summarized best by like the first comment that somebody left, where somebody's like, this isn't even really hacking anymore. It is just fantastic engineering done by somebody who's super passionate and bringing all of like the modern tools to bear. And, we kind of talked about that a little bit in our weekly meeting, where it is incredible what an individual is capable of now with so many tools, hardware and software available to them, and everything from, professional PCB production to desktop 3D printing. I mean, like it is incredible to see this kind of stuff being made by an individual, and like you said, at least in theory, can be reproduced by others. Certainly not a walk in the park necessarily, but if you need these things bad enough, can't afford the big ones, and you want the budget version, you'll put the effort in, right? And I guess it's a little unfortunate for, you can't change the name of the site now. It's been Hackaday for too long, right? I don't know what we would change it to, but like, it is just incredible to see just the state of the art of, if not hacking, individual hardware fiddling, whatever you want to call it, right? And I think this is a perfect example of that, and just it sets the bar so high, and it's even if something that personally I would not have a use to, I just love to see all the thought and the effort that went into something like this, and then to share that with everybody else, right? I think is really the defining thing. I think that's what still makes it a hack, maybe, right? Is that you're still willing to go out there and share with others, and it's not like you take your ball and go home with it. Like, it's that hacking spirit anyway, if not in the literal sense.
Yeah, and this one is totally made possible by 3D printers. Comes up in the comments here, there's a good discussion about the various gear types, because Caden actually mentioned that he'd never seen anyone else using gear shapes just like these before and wonders why. There's a couple reasons. One, he doesn't just make cycloidal gear profiles, he actually then takes them and herringbones them so that they mesh together and there's really no backlash, which would be essentially impossible to machine. There's like no good way to do the subtractive machining for these, and so you never see them. The other problem with cycloidal gears, and the other reason you never see them, is that the spacing between them has to be very precise. But again, 3D printing, you can get these things within very good tolerances, even if you're a random hobbyist. Like, that's kind of to your point. It's amazing to see what the hobbyist level is at right now. Which brings me to the next robot dog in my twofer here. This is Ed Musa's From Leash to Locomotive, Kara the Robotic Dog. And we followed this one before. He was working on capstan drives instead of gear drives. So while Cadence has these awesome custom designed gears, Ed says, I don't even need those. I'm just going to use different sized winding capstans and rope in between the two of them. In a previous video, he worked out this whole capstan drive, and that was maybe, a few months ago, maybe even a year ago, and I've been sitting on the edge of my seat waiting to see him put this together into a working robot, and that's what happens in this video. It goes through all of the kind of integration woes and troubles and programming it, and so he has to do all the inverse kinematics himself. By the end of it, he's got an IMU working with it so that the robot is actually a little bit self-balancing, and he demonstrates this by lifting up the table it's on, and you can see it kind of canting over so that it doesn't fall over. Really, really cool. He's using off-the-shelf motors, but then his own assemblies with these capstan drive gear reducers and stuff. Again, stellar hacker engineering project. His suggestion in the previous video, and I think it's borne out in this one, is that doing capstan drives is a super good fit for 3D printing, because a lot of the blobbies and inaccuracies and whatever you have in making gear faces will not matter so much for capstan drives, where you're just winding a rope around, in this case grooved, but basically just a grooved cylinder. I agree with him that in terms of making easy gear reduction with no backlash at all, doing it with string, with, in this case, Dyneema, really unstretchy string, is kind of a perfect fit for 3D printing. And so I'm stoked to see this one turn into a robot dog. He is working on a simplified version of it, and when he gets that done and open sources the plans for that, I will be even more stoked. If you've been seeing the big players playing around with their various awesome quadrupedal robots, the time is coming, people. We're going to have cheap motors pretty soon, and we're going to have a beautiful design for slightly more expensive motors coming out. Keep your eye on these two projects.
I was going to say, I for one welcome our new robot dog overlords, and I'm very excited to do their bidding. Please remember that when the revolution comes. All right, well, my last one here is, what will it take to restore a serious flight simulator? And I picked this one because this is something that's kind of always been, the long list of things I wish to one day find in the garbage and repurpose is something like this, like a proper flight simulator it's more than even just a cockpit. It's actually like Jared in the video refers to it as an actual flight deck. There's multiple chairs, and it's like a kind of thing where you'd have a projector in front of you and like a fully immersed flight simulator setup. And this is actually a proper FAA certified like training simulator, but like all kinds of certified and registered equipment, if you don't keep up on it, it can lose its certification, and then its value drops considerably. And that seems to be what happened here. This one was no longer up to snuff, and it ended up going at auction. He doesn't mention for what, but he says very, very cheap compared to the the 6-figure cost this thing would have had to start with. The problem is, I think that's probably the big takeaway from this video, if you watch it, is that really nothing works as is, and probably never will again, because all of it is so proprietary and hush-hush that there is no documentation for a lot of this stuff, and there is no parts, and this isn't the kind of thing you're meant to work on, really. You're meant to buy this for, $250,000 or whatever and train your pilots, and if there's a problem, then you call the company that made it, and they do everything, right? So there's just nothing out there on how any of this stuff works, and it looks like the reality is bringing it back is going to involve a lot of new electronics just housed in this flight deck, which itself is still pretty cool, right? Because you still have all the controls and the pedals and the handles, for the throttles and flaps, and you got the seats, and you have basically a whole, nose of an airplane. It's still worth it for all that, but it is interesting to see just how much electronics are in there. And, Jared goes through and he says, oh, this is cool, but I don't know how to make that work, so we'll probably replace that. This is cool here, but I can't find any information on it, so we'll probably have to start from scratch. And there are some interesting things that look like, to me, they wouldn't be terribly hard to recreate. Like one of the details I particularly like, and we've certainly seen this in, like, DIY flight sim projects. I can't think of any exact example right now, but if I find it, I'll put it in the notes. Basically, there's a trick where instead, you have, obviously, a plane's got all kinds of gauges and stuff, and to do each one of those gauges individually is very time-consuming, very expensive. So there's an idea where you just get, like, a laser-cut piece of acrylic that has circles in it, and then you put a regular computer monitor behind there, and then in software, you can put little virtual gauges in all those cutouts, and you save an incredible amount of time of wiring and, the parts, and you just drive everything in software. That's how this flight sim was set up. So, in theory, recreating that is relatively easy. He mentions that the screens that are back there apparently are blown just from, like, the number of hours on them, but it should, and there's a lot of, air quotes here, it should be as easy as just putting a new LCD behind them and writing some code. He's talking about probably using Raspberry Pis to drive the displays. Get Pygame or something, and you write some code to show little virtual gauges at the proper coordinates, and you're halfway there. This is like this isn't even step 1. This is like step 0, where he's really just going over it and talking about what is and isn't there. It's going to be a long project. I believe, actually, right before we started recording this, he dropped the second video. I didn't get a chance to look at it, but he's looking for a lot of community help on this, and I think it would be cool to see what kind of. This is the sort of thing I think will inspire new development for flight sim stuff. You're going to need to be able to design some new hardware and software to integrate with this, and I think it's probably going to move the state of the art forward a little bit for everybody else, even if you don't happen to have a $250,000 cockpit simulator in the local dumpster. So I think it's definitely one to watch, and as somebody who personally has been into flight sims and that kind of stuff, it's definitely on my short list. Every time I see a new video drop, I'll have to check it out.
Yeah, it's fun to imagine working on something like this, because it is, like you said, like a whole bunch of small unsolved problems, and probably they're all decoupled enough that you could work on this part of it, you could work on that part of it, you could work on that part of it, and you could maybe make slow incremental progress on the thing. And that does look, if you don't have a day job, that looks like a great thing to spend the next year doing.
Yeah, he talks about stuff like, there's like the central column has like all the avionics, and from the front they look like legit panels. Again, this is a very high fidelity model meant to train you on actual aircraft. But on the back, it's surprisingly, for something that is as expensive as it is, it's surprisingly straightforward. You know, how all the switches and stuff are wired up. You know, he mentions that each one of these little panels has like some kind of a backpack, for lack of a better word, that seems to be taking all of the various switches and buttons and converting it to some kind of like a serial bus.
CAN bus. I hope it's CAN bus.
Well, right. That's a lot of it is still in the hoping stage, right?
Yeah.
Like, you know, we don't know exactly what it is, but you know, he's like, hopefully, like when we power it up, we'll be able to sniff it and see what these things are talking. And maybe it's something that they can work with. But he said even if they can't, at least they should be able to make new little backpacks for all the panels. You know, like so the panels themselves and all their switches and lights and stuff can still work. They'll just need to do a little bit of that glue logic to say, okay, well, you know, let's turn them. We don't know what the original protocol was. Maybe it was some proprietary thing, but now let's make them I2C devices. You know, something like that. And then, like you said, that there's a lot of subsystems that you could kind of, and maybe even if that's something that the community ends up doing. You know, one group could be working on this and getting that going, and somebody else is working on getting the flight yokes, and somebody else is doing the pedals. And at the end of the day, you know, hopefully you have something that works.
Oh boy.
Uh-oh.
My next hack is not just a 1-fer or a 2-fer or a 3-fer. My next hack is a 4-fer. I decided I would cover all of the entries in the One Hertz challenge that we covered last week.
Oh boy.
So here goes. Here goes. It's like a mini quick hacks One Hertz challenge edition. And I wanted to start off with Ken Yap's One Hertz challenge. An ancient transistor counts the seconds. And here he's using a germanium transistor from way old stock to make an oscillator that I'd actually never seen before called a Garner oscillator. If you want to do a little bit of a mini deep dive into some crazy old analog electronics, you should check this one out. I ended up following that rabbit hole down to Michael Covington's website where he writes up this oscillator. If you try to recreate this using non-germanium parts, it actually doesn't work because they don't have enough leakage current, and that's part of the secret sauce, is that back then transistors were leakier than they are now. Next up, Jim Matthews' ham radio fox hunt transmitter. This one is lovely simple. He takes an off-the-shelf walkie-talkie module and he wants to use it for fox hunting. So he hides this somewhere, and radio people use direction finding to see if they can figure out where it is. To do that, this thing has to beep once every second. Haha, 1 Hertz challenge entry. Congratulations. Normally, the module is set to press a button to make it fire. Here he simulates the button pressing with kind of a DIY optocoupler made out of a flashing LED and a phototransistor, butted end to end and put into heat shrink. The absolutely minimalist, hilarious part is that it's one of those automatic flashing LEDs that has the little microchip in it. So he doesn't have to do any programming, any work, any thinking even. He just makes this funny self-firing opto, solders it onto the walkie-talkie, and boom, he's done. I love it. Dan Jovic made a Valvano clock, which is basically a seconds counting clock. This one's a simple project. RTC, OLED, Arduino Nano. Put them together and you've got a clock that counts the seconds away, 86,400 of them a day, and rolls over. I think this was Swatch's internet time gimmick or whatever, but I guess the daily version. And bringing up the rear, Mike Coates' project, Metron Almost, is gunning for last place. This one made me laugh so hard. It's a metronome that never beats 1 time a second. And he's just like trolling us. And I so love that. I just totally appreciate it that we put out a once a second contest and he takes the effort to draw a Gaussian distribution between a half second and 1.5 seconds, have it tick every so often, and then he notches out around the 1 second mark. So it never ticks once a second, except on average, it does tick exactly once a second. So if you let it go for a day, it's probably going to tick about the right number of seconds. But if you listen to it, it is absolutely maddening because it's so erratic that I agree with his quote here. Leaving the metronome almost running for any length of time really seems to put your nerves on edge. You could watch the video and test it out yourself. It drove me absolutely insane, and I was watching it for like 10 seconds. It's horrible, and I love it.
Well, if that's not a description of so many of the projects that we see, it's horrible, and I love it. What can I say other than, there's been just awesome entries into this contest, especially for something that has over a month to go, right? Like, I think it's August 19th is the cutoff. So we're seeing a lot of activity, and I think we have kind of noticed that in general is the community seems to respond really well when you give them a constrained parameter, reasonably or otherwise, and whether it's like it has to be certain size or has to use a certain amount of power, or in this case it has to do something at 1 hertz. I mean, they really seem to like that, and it kind of bears out with the number of submissions and the quality of them. So I'm really excited to see what the next month is gonna show.
We gave you one thing it had to do, and 3 of them did it, and 1 of them did everything but that. It's like perfect.
Well, I picked this one because, I think when I saw it go out over the weekend, I did not give it the attention I think it deserved, because I was blinded by the headline and the picture. So that's my mistake. You gotta read farther than the headlines, folks. It's an important lesson, because it looks like this is the J-Corp Nomad ESP32 offline media server in a thumb drive, and it looks for all the world like a USB flash drive. And I said, well, that's not terribly exciting. Okay, you put some videos on a flash drive and then you plug them into your computer and you watch them. Okay, sure, why not? But then, I kind of stuck it in the back of my mind, and when we're looking at things to talk about for the podcast, I was like, let me go back and see what that was really about. And it's actually pretty fascinating to me, because I think this is a great example of just how far microcontrollers have come, and how we're starting to really see this blurred line between what you do with a microcontroller and what you do with a full computer like a Raspberry Pi. In this case, you've got an ESP32 coupled with a SD card reader. So the hardware is very straightforward. I mean, you could do this with literally what's in the junk box. There's nothing special going on there. The code essentially stands up a Wi-Fi network on the ESP32 and handles all, people connected to it, and runs a web interface that pulls from a rudimentary database of the media that's on the SD card, and gives you this very nice unified, hey, here's music, here's pictures, here's movies, and they, the videos, you can have shows that break down the seasons and stuff, and it's not the most advanced media playback UI I've ever seen, but considering what it's running on, it's pretty wild. And then you can, click on a movie and it streams it to your device. And the cool thing here is that because it creates its own Wi-Fi hotspot, it is the media server, right? So, Jackson Studner, the creator, talks about, using this like when you go camping or something. You can have this hooked up to a battery bank, and everybody's on their phone, and they're on their phone, and they're pulling the movies and the music and stuff from this, little thumb drive sized device. And he had mentioned that originally he was going to do a Raspberry Pi, right? Which I think is probably what most of us would, if someone was describing this project to you, you'd say, okay, I'll get a Pi Zero or whatever. And realize, hey, any more Raspberry Pis are not the cheap little computers they used to be. And ESP32s are comparatively going for pennies. So, could I pull it off on this more restrained hardware platform? And he does. And, ESP32 isn't like transcoding the video or anything, or that you might expect from like a big boy media server. But, I mean, for what it is, it's really impressive. And I think it kind of just shows that the microcontroller is not the microcontroller that some of us still think about. It's not the 8-bit AT Tiny that gets winded blinking some LEDs. Like, you can do an incredible amount of stuff with these modern chips, and they're only gonna get more powerful, from here on out. So I think it's gonna be very interesting in the coming years. to see, like, what do you reach for? You know, like, do you really need to get a whole computer with a whole operating system just to share some media files? Or, you know, is your dual core 200 megahertz thumb sized microcontroller more than up to the task, right? And I think the answer is increasingly going to be that, you know, the microcontroller can do it. It might involve a little bit more, you know, efficient coding on your part, but there's nothing wrong with that, right? So I think it's just a really cool milestone, and I think it's not going to be the last time we see a microcontroller pushed into a job that we would normally see a proper computer doing.
Yeah, and this project has legs in so many different ways. It's really interesting. Like, one, his hardware here is a little bit custom, but there are also Chinese companies nowadays that make super cheap modules where it's like ESP and an SD card, right? So you can just buy one of those, flash the software on it, and you're good to go. You know, you have a power bank with you, you plug this thing into the power bank, and 4 people can watch videos on this thing, you know? So you just, whatever, you take it on the plane with you, you watch, you know, you and your wife can watch videos at the same time on your different screens, right? Like, it's really super cool. Already it supports what? PDFs, MP3s, and movies, but then a couple people come in the comments and they're like, oh, it'd be cool if it did FLAC and WAVE. And Jackson comes in the comments and he's like, oh yeah, cool idea. I'll get on that, right? Wouldn't it be fun if it would work on this hardware? And he's like, oh yeah, maybe we could port it to that. And I'd love to see a couple other people jump in on this and help port it off to random platform X that has an ESP32, S3, and some kind of media on it, because that's really all it needs. I'm looking at my desk right now, and I have 3 different things within easy reach that all meet this description, right? So, like, there's a low bar of entry and just a super fun, convenient little thing to have around if you want to share your media with other folks.
You know, as much as I like the one-offs, right? Like, and you know, you could say the one-offs are kind of our bread and butter for a site called Hackaday. We need a lot of one-off projects.
You think?
I really like the ones that start a community and grow beyond, you know, that immediate need. You know, this is not something that, like, oh, I needed something for this weekend. I threw something together and then I'm never going to think about it again. Like, this is something, like you said, has many applications, has a broad appeal, has a low bar of entry, and I think that people will be excited about it. And I think, and of course, it's open source, so you can go in there and say, hey, you know, I want to do a new theme for the user interface, or I want to do this, or I want to do that. I want to add support for different formats, and I think that this is something that is going to grow. And I'd love to check in with this down the road and see what's changed and what's new, and it's just really cool to see the birth of something that you know, a lot of people are excited about and a lot of people are putting effort into.
All right, my first quick hack this week is a stunt hack from Stefan of CNC Kitchen. Introducing Pula filament, grass fiber reinforced PLA. As a gag, he incorporated ground up, dried out cow patties into PLA and tested how it printed. This isn't totally crazy. We have all sorts of fiber reinforced / fiber containing PLAs, whether it's wood or grass or carbon fiber, right? So he's just doing something, granted a little clickbaity here, but, you know, picks some cow patties up, dehydrates them, puts them in the blender, and basically it's just grass at that point. So what's fun here is to watch him go through the steps of making his own custom contaminated PLA and see the various problems he has. Like, he starts off with PLA granules, but everything's too inhomogeneous, and so he ends up using PLA powder, etc., etc. He's using a not very expensive homebrew filament extruder. If you're interested in this kind of weird custom filament stuff, it's a great video to watch. Next up, a collection of lightning detectors from a site called Wenzel Tech, which looks exactly like the old TechLib site, and so I went clicking on it, and lo and behold, it is. What's old is new again. This is a collection of absolutely fantastic, dead simple couple transistor analog designs that make great lightning detectors. I know because I've built a couple of these myself. Next up, Meticulous Technologies USB-C Rainbow Ranger Sensing Volts with Style is just a really sweet build. It's in a crowd supply campaign right now, but he says it'll be open source afterwards. It is a stack up of a few PCBs with nice rainbow colored LEDs underneath that you can plug USB-C into one side, USB-C into the other side, and it'll tell you what voltage is going across. So if you have USB power delivery devices and you want to know what voltage they're using, this is the piece of equipment for you. And last up, Christoph Walcher, Coroutines in C, is a nice write-up of him kind of reinventing the proto-threads library using Duff's device and everything that goes along with it. If you have done any programming in C on embedded devices, you know that sometimes you want multiple things to happen at once. You don't really want the full burden of a real-time operating system. You can do kind of cooperative multi-threading. And that's what coroutines do. That's what the proto-threads library does. That's what Duff's device is a horrible, hacky way of implementing. It's absolutely lovely here. By the end, he realizes that he's reinvented the wheel, but at this point he's described the invention of the wheel so nicely that you really want to read it anyway. Great comments here from Toon and Scott Hess, and Oppie comes in with RIOS, which is a terribly small, lovely implementation of a real-time operating system that kind of fills the same niche as Christoph's project, but in a much less hacky, much more straightforward, kind of more aesthetically pleasing way. So check that out if you like to write embedded code in straight C that does multiple things at once.
My first quick hack is the smart coffee table to guide your commute. And this is not entirely unlike other projects we've seen before, although I can't think of another one that was a table necessarily. But this is the idea where you have a map of where you're at. This is Cincinnati in this case. And you highlight all your important thoroughfares with LEDs, and you can at a glance, thanks to the traffic APIs that must exist in these cities that I certainly don't have access to where I live, you can show what's clogged up and where you should avoid before you get started. And it's a really cool project that, combines woodworking and, kind of all the tools of the trade. There's CNC cut map of Cincinnati out of a piece of wood. Well, maybe the thing that kind of sticks out is that whereas in other ones we've seen, like there'd be a map and like individual LEDs would mark the roads. In this case, Michael, he used a large format 3D printer to print the almost like arteries, right? These like, thick lines where all the roads he's concerned with are. And then inside of those, he's put, off the shelf addressable LED strips. I gotta say, I'm not sold necessarily on the look, but hey, it's not my living room. It's if Michael's happy with it, that's all that matters. I think it might be a little bit of a case where, like, hey, I got a large format printer. Let me print this thing. But it is a really cool functionality wise to be able to start your morning, look down at the coffee table, and see what roads you should definitely not travel down on your way into work. Next up is Blu-ray 1, but at what cost? And this is just kind of an interesting story about the history of Blu-ray from a site called Obsolete Sony, which I'll give you one guess what they catalog on their website. It talks about the transition from DVD and the need for a format that could handle what at the time, HD was 1080. Obviously now we've moved on into 4K and beyond, but at the time, DVDs couldn't hold 1080p video, so there was a need for a new format, and you had HD DVD, which was kind of seen as sort of the natural successor, but then Sony supported Blu-ray, and some of the milestones in that format war, which, you could probably point out as one of the big ones, was with the introduction to the PlayStation 3, Sony put a Blu-ray drive in there, and now all of a sudden everybody who owned a PlayStation 3 wanted to buy Blu-ray movies, and the rest is perhaps history, right? But then it kind of ends with saying, ultimately it doesn't really matter because this has all happened in the shadow of streaming becoming now the dominant form of media consumption. And, there's of course a larger debate to be had about ownership and whether it's a good idea to be streaming versus buying, and that's a whole another story. That the fact of the matter is, everybody and their grandmom is now streaming video, and very few people are buying discs. It actually kind of goes in to say that Blu-ray, they're now doing 4K Blu-rays, but are considered like collector's editions by a lot of people. It's almost like buying vinyl. You're not necessarily even going to play it. You might just want to have it as part of your collection. So in the end, the home media format war was kind of pointless because they both lost to a dark horse that everybody could have saw coming if they weren't so worried about which version of plastic disc they were buying.
Ouch.
And finally, I have this homebrew CPU got its start in the 1990s. And this is a cool project on its own, just because it is real labor of love by Sylvia and Fortin to create this homebrew CPU using, logic chips. And, it starts out as a breadboard and wire wrapped. And what really spoke to me, though, was, like the title says, that this is a project that started in the 90s. And for whatever reason, I don't have to explain it to this audience, for whatever reason, projects end up winding down and going by the wayside, and you sort of forget about them, but they're always in the back of your head. And for Sylvian, when COVID came around and everybody had a lot more sitting home free time, he said, hey, where's that homebrew CPU I was working on back in the 90s? So he dusted it off and he started working on it again and added some new features, and then he put it on his website. And again, I probably a lot of people listening to this know that once you start putting stuff online, you start getting those offers from board houses that say, hey, we'll pay for the boards if you want to put our name on the website. So he got an offer like that from a particular board house, and that went down the whole road of, well, I guess I got to learn how to make a PCB. So now the newest and brightest version is this proper board that anybody can download and enjoy. So it's really just a success story for him personally. But the reason I really picked it was because I think it's just a great reminder that even though one of your projects may have fallen, forget the back burner, it's behind the stove, right? Like, just because it's not being worked on actively, and maybe you're taking a couple years off and maybe you got stumped, it's never too late to kind of go back and dust it off and return to it. And I know personally that is a little bit of a motivation that I need, because I have more projects in limbo than I know what to do with. So just a great reminder that never say never, right? It's never over until it's over.
All right, now it's time for our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I wanted to cover Dan Maloney's Hacking When It Counts, DIY Prosthetics, and the Prison Camp Lathe. Now, Dan had read about a lathe made in a prison camp during World War II by a prisoner of war and wanted to dig into this story. The only thing he could find was a single PDF of an article that was written in 1949, and he started digging there. The story basically goes that Reginald Bradley and his crew of Australian prisoner of wars are caught by the Japanese and interned in a prison camp in Singapore, the Changi prison complex. While he's there, he manages, through luck and social engineering and probably sheer determination, to build himself basically a full metal shop. And one of his fellow prisoners, Arthur Purdon, designs prosthetic limbs. And between the two of them, they are able to outfit the other prisoners of war and actually some of their Japanese captors with prosthetic, mostly legs, but prosthetic legs that are made with kind of precision machining. And that's the part that Dan thought was interesting here, is the precision machining in a prison camp and how he did that. And he has this lovely picture of this lathe that Captain Bradley made. And the question is, how the heck did this happen? And it looks like the story is kind of a combination of begging, borrowing, and stealing. He manages to convince his captors that they have a machine shop, basically. It isn't said whether he offers his services to them in return for being able to run this machine shop, or whether they had some kind of pity and let him run the machine shop for the other prisoners of war there. But however it works out, he ends up spending, he says, about 600 hours over 6 months to make a little mini lathe. And with this little mini lathe, the lathe kind of being the mother of all machine tools, is able to make taps and dies and pivoting joints and everything else that they needed to make these metal prosthetics. And that's really just, it's a fantastic story. They got out of it alive. And so there's pictures of happy people at the end of it and pictures of the designer of the prosthetic at the headline here. And what I really loved about this is that when Dan gets into one of these like history pieces, he actually gets into it. And he went digging through the UK's National Archives and got the like name, rank, and serial number card on Reginald Bradley. And I don't know if anyone has seen that. It certainly wasn't in any of the museums that he went looking for. So he actually dug up this person's prisoner of war internment camp card in Singapore, which I think is pretty cool. And it does also substantiate, you know, all the things that you kind of know about him. That is that A, he was a captain, B, he was trained as an engineer, and in fact was a AMICE, which stands for Associate Member of the Institution of Civil Engineers. So there you go. Anyway, it's a neat story of getting the job done when you have to under adverse circumstances. And that's the point of this infrequent but recurring column that we run, Hacking When It Counts. Pretty cool to see this one. And it was really awesome that Dan did some digging and got us some new first-hand documents on this. I thought that was pretty sweet. We'll see what he comes up with next.
I'm sure it was said in the comments, but like this definitely could be a movie. It's such an incredible story, and I think, you know, I look at the picture of the final lathe, and I'm like, I didn't think I'd ever, you know, be jealous of somebody in a Japanese prisoner of war camp, because how come they have better equipment than I do? You know, it makes me wonder what my problem is, because they were able to put this stuff together with scraps, and you talk about brilliant guys. You know, there's parts of the story that are almost hard to believe, you know, and you do wonder if there's a little bit of, you know, legend going on there, but it was a different time, and, you know, obviously there's a lot of confusion going on during war and that kind of thing. The part that struck me the most was it got to the point where they said it was hard to hide the machine shop, right? Because they had all this stuff out there, and they're like, well, what the hell, you know, we can't keep hiding it every time. So according to the Dan's story here, they said that they had started talking to one of the Japanese guards, saying, you know, hey, we'd like to learn some Japanese. Can you show us the different symbols and stuff? So they start with dog and cat, and they go through all those. And at some point, they make the leap to workshop. And for whatever reason, the guard was like, oh, yeah, this is how you write workshop. And then supposedly they made a sign. Now they knew what workshop looked like in Japanese. They made a sign that said workshop, and then just put it on their barracks. And supposedly everyone just took it at face value and never questioned why there was suddenly a workshop in the middle of the barracks. And from that point on, they were able to work with more freedom. And it's a little hard to believe that at face value, but I'd love to see it played out in the film that someone is hopefully working on.
Yeah, that bit's just a little bit too Hogan's Heroes for me.
Yeah, right.
Well.
It's literally like something I could imagine, like a laugh track. After, like, they put the sign up, and then there's like laughing, and the guard comes by and like, I don't remember there being a workshop here yesterday, but you know, there's probably a little bit of a telephone game going. Maybe some version of that happened. You know, it also does say that they had made friends with. I mean, as much as friends you can make with your, you know, prisoner of war captors, right? Like, they had talked to, you know, some of the people who were in charge and struck up a, you know, common interest, and that sort of bought them some leeway, and they were obviously, there was a little bit of looking the other way, certainly, from the guards that made this happen. And it, like you said, I don't know if it was because he was maybe willing to do some repair work for him, which is not unreasonable, right? Or maybe just, you know, they knew he was, I mean, you know, people were showing up with artificial limbs, right? You had to think they were coming from somewhere. It's hard to believe, like, the guards didn't notice, like, hey, that guy didn't have a leg before. So they must have, you know, they must have known this was happening. And I guess, like, are you really gonna, you know, shut that down? Like, you know, the guys are already got about as bad a situation as you can can get. So I think they definitely lucked out a bit with the leadership at the camp was lenient enough to let this go and kind of turn a blind eye to it. Didn't it didn't hurt them any, right? It wasn't like they were trying to make weapons to escape. Like they were just trying to improve their lives, the other guys. Well, I guess I have to talk about my own one. I always feel weird about it, but I suppose I do know this one better than any of the other ones that have been put out. Well, my own pick will be my own pick. Begrudgingly, I will talk about my own article this week, the fight to save Lunar Trailblazer. I have kind of my ear to the ground for a lot of the space stuff. It's personal interest of mine. There's a lot of stuff going on. If there's ever a time to be like an armchair astronaut, this is the time, because there's so much stuff going on. It's almost every week something's going up or doing something, and it's really cool. In this case, this is the Lunar Trailblazer, which was a low cost, not a CubeSat kind of thing, but I think on the order of 80-90 million or something, which is really pretty cheap for a space mission. And the idea was to get to the moon and scan it at a relatively low altitude for traces of water, which in theory could then influence the landing site for a possible human outpost, because water would be nice to have when you get there. So this is kind of operating under the larger umbrella of NASA's Artemis moon program. You could be forgiven for not having heard about this, because it actually launched back in February. Unfortunately, after it launched, there was an initial signal from the spacecraft that said, "Hey, I'm here. I've separated from the rocket. I'm powering up, and I'm getting things ready to go." They got a little bit more engineering data for about 10, 12 hours, and then it started getting weird. They got messages about the power level. Something's wrong with the power level, the power supply. Something isn't right with they knew something wasn't right with the power. And then it went silent. And a couple hours later, it came back. And then it did that. And that's sort of been the story since February. They have this kind of intermittent communication with Lunar Trailblazer, and you have this short window to talk to the thing, and you can't. How much can you say if the conversation's only a few minutes long, right? It took a little bit, about a week or so after they launched it, they were able to lock onto it with ground-based radar, and then later actually optical telescopes, and they could see the problem was that the thing was spinning, and it was not supposed to spin. Instead of it flying in a attitude that would keep the panels pointed at the sun, it was doing this little rotisserie thing. So once in a while, the panels would see the sun, and it would get this bolt of energy, and it would boot up to some level, and it might squawk out a couple, "Hey, I'm here" messages. But then by the time they scrambled to respond to it, it had already turned away from the sun and lost the power, and it was, sleeping again, for lack of a better word. That's not great. It wasn't supposed to do that. They were in the unusual situation that they knew exactly what was wrong. Basically, it was a very elementary problem, right? It wasn't facing the sun, so it wasn't getting the charge, but occasionally it faced the sun, so there were these windows of brief activity. So what they did from mid-March on is they've been observing it again with radar and telescopes and modeling its rotation and plugging that into some kind of computer model of its position and speed and all that kind of stuff. And they've come up with, basically they know when it's going to be awake and for how long. So then they went to they always have a ground replica of these things. They went to the ground replica and they said, okay, well, let's say the solar panels get hit with sun. How long does it take before this thing's ready to receive a command? Like, what's its boot up time, effectively? And knowing that, and knowing how much sunlight the solar panels would get, there'd be certain times where they had a chance to send it a perfectly timed signal that should arrive at the point that it was ready to receive it, but before it loses power again, right? And it was this very delicate equation that they were just fortunate enough to have all the different variables for. All that being said, it has yet to actually bear fruit, unfortunately, because they still are trying. They said that the model shows that they had opportunities up until roughly the middle of July, which is nowish. There hasn't been an update from NASA. The reality is, if they were successful, we probably would have heard about it immediately. So I think, unfortunately, they probably have not been able to establish communication with it. But I appreciated, one, the transparency of them putting all this stuff on the mission's official website, and two, just it was an interesting look at. You get this idea that, like, if you're stuck out there, you're stuck, right? There's nobody to come out there and flick the power switch, or there's nobody to come hold the satellite in position so it'll charge. So you have these kind of B and C and D plans that have to kick in, and I think this was just an interesting example of how many options there are, even though it might seem at first that it's a lost cause. I would obviously love for it to have been a success story, and there still is hope. They haven't actually said they're giving up yet, but either way, I think it's just an interesting story of just the tenacity of the team, and talk about, like, out of the box problem solving and that kind of thing, and a reminder too that this stuff is not easy. As long as we've been doing these missions, you still have these problems, and even at $80 million, there's still this wasn't like a high school project. This still wasn't a lot of money put into it and a lot of time, and even at that level, you're still running into issues. So it's for all the activity that is going on in space right now, we still have lessons to be learned.
Yeah, right. I just love the idea that this thing is tumbling around, losing power, gaining power, losing power, gaining power. And they're like, we're not done yet. We can still, if we can just time it right. And I hadn't even thought about it until you said this, but of course there's time of flight from Earth to the moon.
Right, right. You gotta take that into account. Yeah.
They have to add that extra bit on the front. I don't know. It's not an easy problem, but that's why they always have these simulators back at home. So if they have any problems, they can improvise and they can figure out what they need to do. And I think that gets them a lot of power as well. I think it's really, you're like plan A, plan B. I don't know if this is plan F or G or LMNOP.
We're into the hex characters now.
This is way down there when they're trying to hit it during the window where it's just gotten enough solar power that it can just boot up. And like you say, I do wish it well. It may be that they're going to have to give up pretty soon. I'm hoping for a last minute save.
And then, you have some people in the talk about the armchair astronauts. They're saying, well, why don't they just put solar panels on all the sides? And I'm like, well, yeah, I guess.
There you go.
Weight is a bit of a concern, so that's a valid, criticism. Like, why not just make it, solar panels on all the sides? But then, you have to take into account the mass and everything. And in many ways, that's the limiting factor.
It has to spread out, right? Like, these are those wing solar panels that you think of when you think of a satellite, right? Like, it's as much surface area as possible. And you can't put as much surface area on all the sides.
Right. And, ultimately, the biggest question, and I didn't actually address it in the article because, frankly, no one knows, the big question is, well, why is it spinning, right? And that's something that is still yet to even be talked about. There will be, and I'm sure it's already started, a formal investigation with all the telemetry they got and all the radar data and all the why did it start spinning in the first place? It wasn't supposed to be spinning, The core question is unanswered for now, and hopefully at the very least, even if they can't get the mission back on track, hopefully they can at least figure out what was that initial fault, what initially caused this instability. And it could be, it might have got hit with something, it could have got hit with a little piece of space crap. And that started tumbling it, and it could have been just a bad luck, it could, maybe there was nothing they could have done about it, So again, it's hard, it's hard to do stuff in space, and this is a reminder. But it doesn't mean it's not worth it, and it doesn't mean there isn't still stuff to learn every time we try.
That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you have anything you'd like us to write about, write to the tips line, tips@hackaday.com. And to follow the links in this show, head on over to hackaday.com/podcast. And until next week,
keep on hacking.
Precise precision.
My first quick hack is smart coffee table turn. Where'd that word come from? Okay. My first quack. Oh boy. You see, that's how it happens. When you make the first screw up, then the other ones are so much easier.
We're calling them quacks from now.
Quick quacks. Quack.
A One Hertz Four-Fer. And a One Hertz 329 times I've read that, and I still get it wrong. Unreal.